Hi everyone, this is a video solution for question number 20 from the chapter 7 bingo problems. This question is kind of weird. It's talking about this piece of cheese. I guess this kind of looks like cake, but it's cheese, I promise. That's on a spring that's compressed 17 centimeters. The cheese weighs, or the mass of the cheese is 1.2 kilograms, and the spring constant K is 1800 Newton over meters. Or Newton meters. So what it wants to know is, when released, how high does the cheese rise from the initial position? So that's going to go up because this is compressed. So based on the information we have, I've already written down the two equations we'll need to use. The first is potential energy equals 1/2 kx squared. Now k is the spring constant, x is the distance, u is and then the other one is u is equal to mass times acceleration due to gravity times the height. So, and that h can also be y. I use both depending on the situation. This one, for me, since it was kind of a real world scenario, I like to use h. Anyway, so what we can do is, since these both have u in them isolated on one side, we can put these equations together. So we can get 1/2 kx squared equals mgh. And really what we're after is h, because that's going to be the height that goes to. And so now what we need to do is isolate the h. So it's really simple, divide over the mg. We end up with h equals kx squared over 2 mg. So now we know now we have manipulated the equation to solve for h. And now what we need to do is plug in the numbers that we know. So we know that that the k is 1800, the Newton meters, the x, which is that compression, is 0.15 meters squared, and then mass is 1.2 kilograms, gravity is 9.81 meters per second squared. So once we throw everything in here, we will end up with, I just realized I wrote the mass in there when I should have written 1800. And then gravity. So now all we have to do is plug that into our calculator. Super easy. And we end up with the h equaling 1.72 meters. So that means that it's compressed, right? When it's let go, that's going to rise 1.72 meters will be the max height that it goes. So anyway, I hope you learned something as always, and I hope to see you in the next video. Thanks.